d of dx, what does this just mean? The derivative of this, and then you're going to say equals. So this just means the derivative. Whenever you see this, this means the two words, the derivative of this. Now you're going to give me the answer, so try to guess it. So the derivative of this equals, the 8 drops in front. You get 8x, and the 8 reduces by 1 to the 7, plus 5 times 12 is 60. X to the 4 drops by 1. Minus 4 times 4 is 16. X to the 3. Plus 3 times 10 is 30. X to the 2. Minus 1 times 6 is negative 6. X to the 0. Do I have to write x to the 0? No, because that's just 1. And what happens to the 5? Constants go away because this is technically 5x to the 0, correct? 0 joins the 5. What's 5 times 0? 0. So every constant just goes away. Okay? All right. So here, for example 5, it says find the points or the coordinates on this curve where the tangent line is horizontal. So I see tangent line. What does that tell me? What do I need to find? Tangent line. Slope. Tangent line. First derivative. Because the first derivative gets you the tangent slope, correct? They want us to know when the first derivative is horizontal, right? Instead of saying tangent line, I can say first derivative is horizontal. Okay, first derivative is also called the tangent slope, correct? When the tangent slope is horizontal, what is the slope of horizontal? 0, right? So when it says horizontal, they're just indirectly telling you slope equals 0. So I want when the first derivative is what? 0. I want when m tangent equals 0. So I want when the first derivative equals 0. Okay? So how do we get the first derivative? M tangent. What is it going to be? Take the 4, drop it in front, using power rule. 4x to the 3 minus 12x. What happens to that 4? It's gone. Now some people are like, oh no, it's cubic, I'm going to have to do synthetic division. No, you're not. What can we do to solve this? This is just grade 12, mix of grade 11. How do I solve this? Because I need to find the x values where the tangent is horizontal. Take a 4x out, and I'm left with x squared minus 3. Now I have to find the x values where those exist, right? So in grade 11, we were taught to take each of the factors after you factored it, in this case GCF, set them equal to 0 and solve, correct? So we're going to get 4x equals 0. So x equals, divide by 4, divide by 4. What's 0 divided by 4? X equals 0. So that's one of my x's that will, one of my coordinates that will get a horizontal of 0, right? So I'm going to put that over here. 0 and something. I should find out, bless you, what that something is. Then I need x squared minus 3, correct? Equal to 0. So I go x squared minus 3 equals 0. X squared equals 3. Then I take the square root. And I know in grade 11, no matter what teacher you have, you are taught that when you do this physical movement, what do you have to remember to do? Plus or minus. Kyle, I taught you. I know, when you do this movement with your arm, that's exactly what I said at 30F Fun last semester. I have other people to back me. Anyone else in my classes, when I do this motion, we put a what? Plus or minus? Okay. Kyle. Okay. So we have two other x values as well where the horizontal tangents will happen, correct? We have one coordinate, 0 and something. We have another coordinate, root 3 and something. Guys, please stop talking. And then we have a third one, that's root 3 and something. How do I get to figure out what the somethings are? Plug it back into which equation? The original, because I'm trying to find coordinates on the original where the horizontal tangent is 0, correct? So I'm going to plug it back into this one. So I go y equals 0 to the 4 minus 6 times 0 squared plus 4. So y equals what? 4. So that's my first coordinate, correct? So what I'm saying is, when I look at the graph of x4 minus 6x squared plus 4, 0, 4 is going to have a horizontal tangent. So that means it's a max or a min or a point of inflection. Remember how we talked about horizontal tangents or max, mins, or points of inflection? Let's try and find the next one. So we go y equals negative root 3 to the 4 minus 6 times negative root 3 squared plus 4. What happens when you get a negative to a 4 power? Fourth power. Becomes positive, we know that. What happens when you get a root 3 to the 4? What's it going to become? It's going to be root 3 times, it'll be 3 times 3, which is 9. Well, it's to the 4, so it's like this. It's like looking at this. Is that not what negative root 3 to the 4 is? Right? What's negative root 3 times negative root 3? 3. What's negative root 3 times negative root 3? And what's 3 times 3? 9, which is how I got a 9. Right? Whenever you have anything to any exponent, you could just draw it out a whole bunch of times. Yes? Okay, minus 6. This one's easier. The squared squares the negative, makes it positive. Squared squares the square root. I'm left with a 3 plus 4. So I'm going to get 13 minus 18. What's that? Negative 5. What happens when I square and 4 through to positive root 3? It's going to get the same answer, correct? Just because they're even. I'm going to get negative 5 here as well. Okay, I chose this computer because it has an actual calculator on it. What I want you to do is type this one into your Y1, please. Every single one of you. And every single one of you is doing it. You can go grab your calculator. Okay, so in our Y equals, we are going to have x to the 4. Can someone tell me what it is? Because mine starts. Minus 6x squared. Okay. Everyone paying attention? Okay, cool. We need the equation where the horizontals are 0, correct? Where do we suspect that those are going to be? I told you the horizontal lines are going to happen at minimums, maximums, and the points of inflection. So where we go from a max to a max in curve, or a min to a min in curve, right? So let's look here. I'm suspecting that there is going to be 1, 2, 3 points, isn't there? Because this one has 2 mins and a max. So we can double check our work and see if those coordinates are those coordinates, right? Now, do you think that Mrs. Lepp is going to give you full marks if you just give me the coordinates of the mins and max with absolutely no work? No, you use your calculator. I'm not like, you can find a maximum with your calculator. I'm very proud of you. You will just get no marks for it. But I'm glad you still know how to do that. So that's good. So what I can do, though, is go second trace value. And I can go negative root 3 if I so choose. And look, it's at the minimum, correct? Could I just calculate the minimum and see if it is the coordinate I just found? Yep. Then I can go 0, enter. Oh, wait, it's the maximum. And then I can go root 3, enter. And now it's the minimum, so I know I'm correct. Okay? So you can double check horizontal tangents because they should be where your max and mins exist. That's the point. That's why we won't need our actual calculators to get maxes and mins anymore. Because we can find horizontal tangents, so we can find where the slope equals 0. tangent slope equals 0, the first derivative equals 0, we have maxes and mins with our calculators. And that's why we couldn't ask you to do algebraically in grade 12. You had no derivative. All right. Here it says the equation of motion of a particle is S equals 2t cubed minus 5t squared plus 3t plus 4, where S is measured in centimeters and t in seconds. Find the acceleration as a function of time. So this is something to note. If I give you like the distance or the motion particle, the motion or distance, the first derivative of that is velocity. So if I ask you anything about velocity, you're going to have to find the first derivative of this formula. Did I ask you about velocity? Did I ask you velocity? No, I asked you what? Acceleration. Acceleration is actually the first derivative of velocity. So if it's the first derivative of velocity, and velocity is the first derivative of distance, what is acceleration actually for distance? Second derivative. The thing about derivatives is you can't just take the original and find the first derivative. You can't take the original and find the fourth derivative like that. You actually have to find each previous derivative to get the next one. So if I want the second derivative, I have to find the first and then take the derivative of that to get the second. There's no skipping. Okay? So here, I want to find the acceleration as a function of time. What is the acceleration after 2 seconds? So I want a of 2. I want technically a of 2 equals what? True? I want the acceleration at 2 seconds being time. So I want a of 2. So I can't find a of 2 until I actually have the equation of a of t, right? Let's say. So if S equals 2t cubed minus 5t squared plus 3t plus 4, then S prime, or the first derivative of S, actually equals V, which equals, so S prime equals V, we agree, which is what? 6t squared, 2 joins the 5, minus 10t to the 1 plus 3. Didn't ask us anything about velocity though. We want the second derivative of S, which is equal to the first derivative of velocity, which is equal to acceleration, which is what? 2 times 6, which is 12t minus 10. We agree? Now what we want is acceleration at 2. So what am I going to have to do? I want it at 2 though. You're substituting the 2 in for t. Once you have the acceleration formula, it's easy. You guys are all not speaking, but every single one of you knows that that's what you're supposed to do. So if I do a of 2, it's going to be 12 times 2. That is not a 2. That is a t. 2 starts with a t. A of 2 equals 12 times 2 minus 10, which is what? 14 what? Meters per second squared. Acceleration is meters per second squared. Velocity is just meters per second. Well, length per time, and then length per time squared. Whatever the length of the time is. Yeah. Why did we say meters in the first place? There isn't even a meter up there. I don't say meters. I just followed what people said. All right. Okay. So we're going to talk about the derivative of e to x. I talked about this yesterday. Now, what I want you to do is I want you to find out what e to the 1 is. So there are two options of which we can do this. We can go second ln, so second natural log, so ln log base e, which is e to the x. I gotta get out of the screen. Second ln to the 1. So that is what e is. It's 2.718281828, and it just keeps going. And that you can use if you have e to the 1, e to the 2, e to the 3, e to the 4, you can use that spot. If you just need e and you want to go to a faster way, you can just go second, no, alpha this, oh, second this, which is the same thing. I always just use that one because I just put it to a 1 in it. So e is a number. We agree? Okay, watch this. Paying attention? I want you to realize this. So, in your calculator, so you can see a little clearer than in mine, put 2 to the power of x in your y1. So 2 to the power of x in your y1 and press graph. And we learned about this in 30-1. This is just a doubling graph, correct? Doubling. Base 2, base 2, base 2 is a doubling graph, right? When you had a base 2, you doubled every single time. If you had a base half, you were half-life. If you had a base of 3, it was tripling, right? We learned that. Okay. So 2 to the x. What about in y2 if we put 3 to the power of x? It's tripling, so it's growing faster, correct? Yes? Those ones are not new to you. Now, put in y3, put in e to the power of x. Remembering that e is just a numerical base, right? 2.718182818, blah blah blah. So it falls in between those two, does it not? It's closer to the 3 to the x one, though, isn't it? Why? Because it's 2.71828. Like that's closer to 3 than it is to 2, right? It's just a number. Is my point. E is a number, just like pi is a number. Okay? So, when you have a numerical base, which is what e is, to a variable exponent, you have to follow a chain rule, which I'm going to teach you ahead of time. You can just memorize that the derivative of e to the x is e to the x. That's true. But whenever you have a numerical base, so say I had 2 to the x. Do you see that? That's a numerical base to a variable exponent, yes? The derivative of that, so d over dx of that, what you would do when you have a numerical base to a variable exponent, everything we've dealt with so far has been a variable base to a numerical exponent. We just do power rule, we drop a number in front. This is the opposite. You have an exponent that's a variable. What you do when you're doing the derivative of it is you rewrite it. So our first step is to rewrite it. Then you ln the base. So your next chain, which is a bracket, you ln, which is just log base e. You ln the base is 2. So that's our next step. The next chain is ln the base. And then your last chain is derivative of the exponent. What is the derivative of this exponent? What's derivative of x? 1. So did I actually have to write that? No, I didn't. So derivative of 2 to the x would be 2x ln 2. And I wouldn't have to write that 1, correct? Because anything times 1 is itself. Yes? So y is the derivative of 2 to the x, 2x ln 2, but the derivative of e to the x is just ex, not ln e. Well, let's see. So, if I use the same rule, d over dx of e to the x, so the derivative of e to the x, my first step is to rewrite it. So I rewrite e to the x. My next step when it's a numerical base to a variable exponent, is ln the base. So it's going to be ln what? Ln e. And then the derivative of the exponent. What's the derivative of x? 1. What is ln e?
1.
It is 1. And the reason why is ln is just log base what? Log base e, and then what's beside it? An e. What happens when you have log e of e? It's just 1. Because log a of a is 1, log b of b of 1, log 7 of 7 is 1. This will result in 1. Now, why is that just 1? Because log base e of e is the same as log e divided by log e, which is just 1. That's why they wrote as 1. So log base a of a is 1. So log base e is 0. We taught that in 30-5. So this also becomes a 1. So e to the x times 1 is just what? E to the x. So that's why e to the x stays e to the x. Because ln of e is 1. So what you need to take away from this is if ever you're asked to do the derivative of e to the x, it is just e to the x. All right. So if f of x equals e to the x minus x, find f prime and f double prime. Yeah, it's a non-terminating, non-repeating decimal. E. It's Euler's E. It's used in a ton of formulas in engineering and in calculus based. So it comes up in chemistry and stuff too. Yeah, but it comes up in a ton of formulas that we just didn't touch because we never touched base E. So in 30-2, they do these things called regressions. And regressions are tables of values. So you get x values that correlate with y values. So just coordinates that are on the graph, right? And they take the coordinates into list 1 and list 2, and then they'll spit out an equation that best fits that data. So they'll spit out a quadratic for them. They'll give them a quadratic equation, or it'll give them a linear, or it'll give them a cubic, or it gives them an exponential, or it gives them a log. And the log equations that it spits out are always lns. They're ln's. They're all log base e. That's what best fits it. So Euler's, he came up with this e, just like pi is used for circles. That's used in a lot of other equations, and it's used in log base formulas. So it's the pi log base 10. It's the next common base that's used for logs.
Okay. Where do we get e from? Where does it number come from? Because I know pi comes from the circumference.
Well, that's because you're using a circle. Euler's.
Where does e, like, what does e represent?
I don't know what I just did. It came back. I touched the cord. F prime of x equals e to the x minus x. What's the derivative of e to the x? E to the x. Minus, what's the derivative of x? What's the derivative of x? 1. Done. That's the first derivative. Now, to get the second derivative, I have to take the derivative of the first derivative, correct? You need the previous derivative to get the next one. So, if I take the derivative of this one, what is the derivative of e to the x? E to the x. And what's the derivative of minus 1? 0. Do I have to write a plus 0 or minus 0? No, I'm done. That's it. Yeah. Yep. Okay. So, if I take -1 and I want to find the derivative of that, I need to use power rule. So I have to take the exponent, drop it in front, and then reduce it by 1, correct? This one has an exponent, and it actually has an x. It's just not written. So if it's not written, we have to write it as x to the something, right? So it is actually every single constant function. So say we have 3x squared plus 6x plus 7. This is actually x to the 0, right? If it doesn't have an x, it's a constant. Its x is x to the 0, because anything to the power of 0 is just 1, correct? So if I do the power rule from this, then I drop the 0 in front. I get 0 times -1. and then it becomes x to the negative 1. We agree? And what's 0 times negative 1? 0. And 0 times x to the negative 1 is 0. So any constant will turn to 0. It'll go away because every constant has an x to the 0 as its actual variable, an exponent, and the 0 drops in front and cancels the whole thing off. Does that make sense? All right. Then we're going to flip over. Why is there such a large gap in this? At what point on the curve y equals e to the x is the tangent line parallel to the line y equals to the x? We talked about parallel and perpendicular yesterday. It was taught in grade 10. Weird, we're back to grade 10 again. Me saying grade 10 every single day. Because grade 10 is so important. Find a grade 10 child and tell them to do well in math. Learn things. Okay? So, we want to know when the tangent line, what does the tangent line just mean? Tangent line means first derivative. What does the word parallel mean? If this line is parallel to this line, what does it have the same as? Same slope. Parallel means same slope as that line. Perpendicular would mean get that slope and then do what? Flip it and negate it, right? So if it was negative, become positive. If it was positive, become negative. So parallel means same slope as. Same slope as this. What's the slope of that equation? 2. So n equals 2. So they want to know at what point, so what coordinate, we need some coordinate, on the curve of y equals e to the x is the first derivative equal to 2, correct? So we want first derivative equal to 2 is what they're essentially saying, right? So let's find the first derivative. So if we have y equals e to the x, it's not going to be rocket science. Y prime, which is the first derivative, is going to equal what? E to the x. You will learn to be very excited when you see an e to the x, because it's just itself. It's the best derivative ever. Okay? We're going to bring back some 30-1 logs and exponents here. So we need to make the first derivative equal to 2, correct? So we're going to have e to the x equals 2. Remember, e is not a variable. E is a number. Yep, that's what I was going to say. E is a number, and the number is 2.71818288, blah, 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 right? It's a number. The variable is in the exponent, and last year, not last year, well, yeah, that technically is last year. Last semester, which was last year, you guys learned how to get that x to come down, because where it is currently, we can't do junior high mathematics and isolate x, yes? So your teacher said to you last year, how we get that x to come down is we have to do what? Convert it to a log. Yes. How you get that x to come down is we have to convert it to a log. Every time you convert it to a log, it'll always equal the exponent, which drops that x down. That's why we convert. So logs, you have to have logs and exponentials together, because if you have a log and the variable's locked beside the log, or the variable's locked in the base, the way we can unlock it is to convert it to exponential. And an exponential, where the variable's locked up here, the way we can get it to come down so we can do some grade 7 math, grade 8, 9 math with some logs in it, is to convert it, right? That's why we convert. That's why logs and exponentials are besties, because it's the only way you can actually solve each of them is using the other form. So if I want to get this x to come down, I do log base what? Yeah, so as a reminder, I'm not sure how you were taught, and then don't care, you can convert it however you remember. But the base of your exponent will always become the base of your log. So if this is base e, then this is base e. That's what I always remember. The base of my exponent will always become the base of my log. Don't what me, you were in my class. It's gonna be the jacket. I'm gonna retire early tomorrow. Okay, so the base of my exponent becomes the base of my log. What goes beside it? 2. If the x went beside it, you'd be moving nothing, and that's not called converting at all. You would just literally be writing what you have. Yeah?
Yeah.
Base of your log, base of your exponent becomes the base of your log. The 2, and then it equals, weird, it equals the exponent, which is what you need. You need it to come down, right? Make sense? And that's why you convert to a log from an exponential, because it's the way to get that exponent to come down so you can do math. Math that you've learned in previous years, right? So that's my x. Perfect. It actually can't be any nicer than that. Well, it can. I'm gonna write it stupid like this. Log base e of 2. It'll never be written as log base e of 2. What's it going to be written as? What is log base e? It's ln. So they're going to write it as ln of 2. Because log base e is the natural log. Natural log, which is ln. ln. How do I get the y? Plug it back into where? The original, because I'm trying to get a coordinate on the original. So I'm going to get y equals e to the x, but x now is ln 2. Do you remember this rule from 30-1? Ln is the same as log base e of 2. We agree? That is a true statement. Everyone agrees with that statement. So I could write this as e log base e of 2. Yes? Do you get what I'm saying?
Yeah.
When the base of your exponent and the base of the log, if it's in the exponent, are the same, your answer is just what's sitting beside the log. It's 2. So if I, for example, if I gave you 2 log base 2 of 6, what would my answer be? It's 6. When this base and your exponent base are the same, your answer is what's beside it. It will always be. If you don't believe me, type it into your calculator. Type in e log base e of 2 and you're going to get 2. So your y value is actually 2. So if you have a variable base and then it's raised to a log, those bases are the same, whatever's beside it actually. Kids taught in 30-1, but they don't use it a lot. It is 2. I know, I'm not a liar. It's crazy, hey? She didn't believe me at all, so she typed it in. And now believe.
Just the first, the second process. Actually, I'm so processed.